Very good evening to one and all. So, hope all of you are fine. So, on last class, we started discussing about the sheet metal forming process. So, there you discussed about what we understand by a sheet metal forming, and we also discussed about this process is commonly referred to as press working or press forming, and then we discussed about the sheet metal characteristics such as elongation, yield point elongation, anisotropy, grain size, springback, etc. And then we also understand what does it mean by shearing, and we also familiar with the basic shearing operations like blanking, punching, slotting, fine blanking, flanging, hemming, seaming. So today we are going to extend our further discussions to bending, the bending sheets and plates, and we also discuss about the spring back. What do you mean by spring back? And also we will look into the bending force. Let's move to the lecture directly. Yeah, the bending of sheets and plates. See, the bending is one of the most common forming operations. Bending is the most common forming operations. So the operation bending, which is not only used to form flanges, seams, and corrugations. So these are actually the bending is usually applied to these parts: flanges, seams, and corrugations. At the same time, it also used to impart stiffness to the product or the stiffness to the part. So the what do you understand by bending? The bending is defined as the straining of metal around a straight axis. You know what is meant by bending. So by definition, I can tell you this is the definition best suited for the bending, the straining of the metal around a straight axis. If you look at this diagram, yes, this is actually what is happening during bending. Now, what is happening if this is how you can bend a workpiece or a part? And if you look at this diagram, you can see that during bending, the outer fibers of the metal are in tension and the inner fibers are in compression. So wherever you are applying this bending operation as a part of sheet metal working or forming, this is actually happening to the part or the piece while it is in bending. The outer fibers of the material are in tension while the inner fibers are in compression. And there is a plane, you can see a plane which is unaffected by both tensile stresses and compressive stresses. This is called the neutral plane with no stresses. Actually, there are three different zones. So the surface which is affected by um, tensile stresses, compressive stresses, that is outer fibers and inner fibers respectively, and then neutral plane with no stresses. So the length of the neutral axis in the bend is called the bend allowance. So when you learn about the bending, this is a very important terminology called bend allowance. And if you look at this diagram, you can see that. So this is the bend allowance. So this is the bend allowance. Okay. So the length of the neutral axis in the bend. The length of the neutral axis in the bend is called the bend allowance. So usually So usually this is the region where the part is bent, isn't it? So usually the, may, this point to this point. So the length of the neutral axis in the bend region, the length of the neutral axis in the bend is called the bend element. So you can use an expression called LB is equal to alpha into R plus KT, where alpha is the bent angle in radians. So if I can draw an angle, so this is the bent angle, isn't it? So if I can draw a horizontal line, I will get an angle alpha. So this is the angle with which this part is bent. So that is called the bent angle. Okay, bent angle in radians, and R is the bent radius, and T is the sheet thickness. You can see that the thickness of the sheet as T, and the value K is a constant which ranges from zero point 0.3 to zero point 0.5. So the value 0.34 where R less than 2 times T. So the value 0.3 for R less than 2 times T. T means the thickness of the sheet. And zero point 0.5 for R greater than 2 times T. So usually we will take values in between zero point 0.3 to zero point 0.5. And please note that the bending operations are carried out using a properly designed punch and a die. The bending operations are carried out using a punch and a die. There are two common methods of bending, that is V bending and edge bending. These are the two common methods of bending. Let's see in detail what is meant by V bending. The V bending means, in V bending, the metal is bent between a V-shaped punch and die. If you look at this diagram, you can easily see you have a V-shaped punch and you have a V-shaped die. Apply the compressive loading to the part which is placed here. So the bending, in V bending, the metal is bent between V-shaped punch and a die. And not only um, the V in V bending, the V dies can be used to make bends of various included angles. You can make, depending upon the angle, you can make different type of V bend. And another type of bending is called the edge bending. So this is actually shown in the second picture. That is, it is done, this edge bending is done using a wiping die. What do you mean by a wiping die and a wiping punch and a die set? The edge bending is done using a wiping punch and a die set. Now what is actually happening is, you can see this is a die, this is a punch. Okay, this is a position number 1, this is a position number 2. Now you can see easily, if you look at this diagram itself, you can easily understand how does the edge bending works. Initially, this sheet metal is held in position by the application of force by a pressure pad. You can keep a pressure pad here so that the sheet metal will be held in position, and after that you apply the force, vertical force downwards using a punch. The punch forces the sheet to yield and bend over the edges of the die. Okay, but please note that this edge bending is very expensive than V bending. Okay, expensive than V dies, because of the V dies are more expensive. And another important aspects related to bending we are learning about today is bending force. The bending force can be determined from the die characteristics and the material properties. From the material properties and the die characteristics, you can easily find out the bending force. The bending force FB is equal to capital K into L into sigma U into T square divided by D. So what is the L? It's the width of the part in the direction of bend axis. Width of the part in the direction of bend axis. So it is clear. Now, if you look at this diagram, so you can see that, yeah, this is the axis which the So this is the L. Okay, so L is the width of the part in the direction of bend axis. T is the blank thickness. You know that. D is the width between the contact points. Now if you are going to make a bending, V bending like this, this is the contact point number 1, this is the contact number point 2. So the width between the contact points is the D, or die opening dimension. It is also called the die opening dimension. And sigma U is the ultimate tensile strength. And the K is a constant, and this K is equal to 1.33 for die opening of 8 times T. And if the die opening or the width between the contact points is 8 times T, what is T? It is the thickness, blank thickness. Then I will take 1.33, and I will take 1.2 if the die opening of 16T. I will take 6.67 for use bending, and I will take 0.33 for wiping die, wiping punch and die set. Okay, so if by using this expression, you can easily calculate the bending force. Now, what do you understand by a spring back? What do you understand by a spring back? See, the spring back, the spring back means, you know that what is actually in bending, you are initially applying a load and the part gets bended, or the part undergoes bending and the part gets bent. Now, in a bending operation, the, how it gets bended, and you are going to apply the load using a punch. The load applied by the punch is removed at the end of the deformation, isn't it? Yeah, at the end of the operation, you remove the load. So at this time, some elastic energy remains in the bent part and it causes the partial recovery of deformation. Which means, so that is called the spring back. That is, the elastic energy remains. So upon removal of loading, the elastic energy remains in the bent part. The elastic energy remains in the bent part, causes partial recovery of the deformation. Not all, maybe the 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 part which is bent slightly regain back, not to the original position, but slightly regain back. So the elastic energy remains in the bent part, causes partial recovery of the deformation when the punch is removed. So this partial recovery towards original shape is called the spring back in bending. Very, very important concept. So the while the industries which are mainly focused in sheet metal type of forming process, this um, the point which we discussed is very important. Spring back. The partial recovery towards original shape is called the spring back in bending. Okay, and then please note that the final bent angle after spring back is smaller and the final bend radius is larger before bending. Please note that the final bent angle after spring back, the final bent angle after spring back, and the final bent radius is larger than before bending. And again, the spring back in bending, you cannot estimate it easily, I mean using theoretical expressions, but you can compensate this using different techniques. We are going to look into it. One is the overbending and bottoming are the two common methods for compensating the spring back. Another method using is the stretch bending. So mainly we are using overbending and bottoming. What is happening in an overbending? In an overbending, the punch angle and the radius are fabricated slightly smaller than the angle required for the final product. Okay, this is how it is happening. In an overbending, the punch angle and the radius are fabricated slightly smaller than the angle required on the final product. So what happens when the metal spring back to the desired value? So as a result, the part when the upon removal of the bending load, it spring back to the desired value. Okay, so if you have not applied this overbending, what will happen? It may have been bent, or it have been bent away from the desired value. So the overbending can ensure the desired value obtained after the bending. So how you ensure that? By keeping the punch angle or radius fabricated slightly smaller than the angle required. എത്രയാണോ നിങ്ങൾക്ക് ആക്ച്വൽ ആംഗിൾ വേണ്ടത് അതിനേക്കാൾ കുറച്ച് ഫാബ്രിക്കേറ്റ് ചെയ്യുക. So after the bending operation, you can ensure that the desired value has obtained. Another important technique is the bottoming. So bottoming involves subjecting the bent area with highly localized compressive stresses. Subjecting the bent area with highly localized compressive stress using a punch. So, um, so this also ensure after bending the part acquires the desired value. Okay, which means we are using a punch to deform the bent region again. So that's called the bottoming. I hope you are understanding. And then finally, another important method is called the stretch bending. So the part is being subjected to tension while bending. So when it is bending, you are apply a small tensile load. So this also ensures that the part acquires desired value after the bending is over. Okay, so these are the three techniques. So we are going to wind up this lecture now. Thank you.